Hi, I'm Jan from NCP Technology. Today in this video I'll talk about how you set the analog input and output levels on the DAD AX32 and Penta 720. One of the great features about these products is that you can actually adjust the input levels and the output levels so it is compatible with the devices that you connect it to. For example, some professional speakers may not like to have a very loud signal. They'll tend to clip. So it is very important that you adjust the input and output levels to the equipment you're connected to in order to avoid clipping in either the converter itself or the following equipment. I'll show you in the DADman software how you actually set that. So in this case here, we are taking a digital signal. We're playing some music via the Dante connection, and that is patched out on the analog output. You can see the meters here indicating the output level. Actually, what we are showing is the digital signal in terms of dBFS, dB full scale. That goes from 0 dB at the top and all the way down to minus 60 dB down at the bottom. So this is the digital level that you're seeing. Down here you'll notice it says 18.0. This means that if you apply a 0 dB full scale, i.e. the maximum digital signal that you can make, you will have 18 dBu output level on the analog side. So the maximum output level you can have with this configuration here is 18 dBu. So this is perfectly suitable for equipment that has a maximum input level of 18 dBu. I can change the analog output level by moving the fader down or up. So in this case here now it is set to 24 dBu. So again, a 0 dB full scale signal will result in a 24 dBu output. Now, if your connected device can only accept 18 dBu as maximum input, you are in risk of clipping the signal when it comes out of the D2A converter in the Penta 720 or AX32. So it is important that you set this so it matches the maximum input level of the equipment that you go into. Instead of changing it with a fader, you can actually also just type in the value down here and set it to a specific value. You will notice here the input signal. So we are patching the analog output from a D2A card back into the analog input here. So these will, as you see currently, be the same level. The reason for that is that we have set the input level here to be 18 dBu. This means that if you apply an 18 dBu signal on the analog input, you will have 0 dB full scale. So the digital signal we have from Dante at 0 dB full scale will, with this DA converter setting, result in 18 dBu analog output. And if we feed that into the A to D converter, we will have 0 dB full scale because the clipping level is set to 18 dBu. I can change the clipping level. So if I have a device that produces more than 18 dBu output, I can actually set it to, for example, 24 or 30 dBu. And you will then notice that the scale on the meters actually drops a little bit down compared to the other channel here, which is still set to 18 dBu. So now with this setting here, you have 30 dBu will result in 0 dB full scale in the digital domain. If you change it now to 9 dBu, you will notice that the digital scale goes way higher than it was before. This is because now you only need 9 dBu to achieve clipping on the digital scale. In order to have 0 dB gain from an analog input to an analog output, it is important that you set the two levels, the output level here, to be the same as the input level. So if you have 18 dBu as maximum input level and 18 dBu as output level, you will have 0 dB gain through the system. So this is how you will set the analog input level. Make sure it matches the equipment that you're connected to. Check out this datasheet for that equipment and make sure that you adjust it so you avoid clipping in either end of a connection.